Okay, so we're going to be doing this today, at least the front side, Unit 2 molar mass worksheet. Once you get going along on this, you'll be, it shouldn't take you long really. But let's, first of all, make sure we understand what molar mass means, which I would write this on your sheet, mass of 1 mole. Okay, so that's all molar mass is. What is the mass of 1 mole? And then the other thing I would say is mass of 6.02 times 10 to the 23rd particles. Same thing, right? Because that's a mole. A mole is 6.02 times 10 to the 23rd particles. So please write that on your sheet. I want that really to be reinforced with you guys. And then I'm going to do some examples so that you should know how to just go through the rest of them as practice on your own. We've done this before already. You guys did, finishing up the POGL yesterday, you did the molar mass of helium. You also did the molar mass of calcium chloride, CaCl2, if you remember that. And we had a, what was the other one? Oh, F2 we had to do. All right, so it's nothing new, it's the same stuff. All you gotta do is first of all figure out what's in it. So in number 1, for example, Cl2. So I look for the capital letters. There's only one capital letter, it's a C. So I know there's only one element. So Cl must be the element. So I know there's Cl, and the little 2 subscript tells me that there are 2. So it's a subscript, tells you how many atoms are in that molecule. All right. So we have Cl twice. So I'm going to go to my periodic table. I'm going to find Cl, which is number 17. And right under the Cl symbol, it says the mass is 35.45. And I'm going to write that down twice. Now, if I put that in AMUs, atomic mass units, I would be finding the mass of an individual molecule of chlorine gas. But we don't want that. We want the mass of a mole. We're doing molar mass. So instead, I can just think of this in terms of grams right now. All right? So I'm just going to do 35.45 plus 35.45, and I get 70.9. Just added them. Just add them up. Yep. So basically, like if I was looking at chlorine, it's Cl2. It's just 2 atoms together. So the mass of this one is 35.45. The mass of this one's 35.45. If I want to know the mass of the whole thing together, just add them together, right? Okay. 2's pretty easy. 3's pretty easy. 4's pretty easy. 5's pretty easy. Number 8, you've got UF6. I'll do this one for you. Why not? So UF6. So I see there's 2 capital letters here. I have a U and I have an F. So that's telling me there's 2 elements. There's U and there's F. So there's U 1 time. There's F how many times? 6. Okay, so I need to write 6 Fs. That's kind of a pain in the butt. Is there a better way to do this, I wonder? Why don't we just do F and make a note of it that it's 6x, 6 times. And if I'm going to do that, maybe I'll also make a note with U that it's 1 time, just once. Okay. So I'm going to look up the mass of U on the periodic table, if I could find it. Where is U? Number 9, uranium. I was just reading a book about this. Pretty cool book. I don't want to say the title. The title's not super appropriate, but it's about the battle between the Allies and the Nazis and their race to an atomic bomb, atomic weapons. So, nuclear weapons. All right, so U, number 92, it says the mass is 238.03. So I'll just write that in here. And since we're going to be talking about molar mass, I'm just going to make it grams right away. We know this is going to be in grams. All right, so fluorine then is number 9. We saw that yesterday, 19.00. All right, so now I'm going to go ahead and do the math because Fluorine is going to be 6 times. Uranium is just 1 time, so that's easy enough. The mass of the uranium in this molecule is 238.03 grams, right? Now the total mass of the fluorine in this molecule, I'm going to have to do 6 times 19, which gives me 114. Maybe I'll put that as 0.0. Why not? All right, so now I've got the total uranium, total fluorine in this molecule. I'm just going to add them together. What was it, Angel? 352.03 grams. That is the mass of 1 mole of UF6. That is the mass of 6.02 times 10 to the 23rd molecules of, yeah, I just added these up. The only time you have to multiply is like if there's more than one atom of that kind, you might want to multiply the mass instead of adding them up a bunch of times, but it would be the same thing. Yeah, if you can. I know it's kind of cramped there. Number 11, though, let me show you 11 real quick. We haven't done a lot of work with parentheses, okay? Which one? No, I'm going to do it for you. And I'm going to erase what's written so far. Is that okay? So when we get parentheses, what these mean? Um, it's because we're dealing with a group of atoms that are kind of stuck together within the molecule. So here I see NH4 in parentheses, and I see a 2 outside. So what that means is it means actually 2 of these. So really 2 times everything in the parentheses. So when I look at the regular formula, I see the N does not have a subscript. So you would normally think there's just 1 nitrogen. That's it. But because it's in the parentheses and the 2 is outside, it's actually 2 times 1. So there are actually 2 N's in this. And then H is in the parentheses as well. It's got a 4 subscript. But since there's a 2 outside the parentheses, it's actually H 8 times. And then we have stuff outside the parentheses that we just treat like normal. There's an S, which is just 1 time. And there's an O 4 times. So if I look up N, it's number 7. It has a mass of 14.01. There's 2 of them, so actually the total mass of it is 28.02 grams. Hydrogen has a mass of 1.01, but there's 8 of them. So if I add 1.01 up 8 times, it would be 8.08. And then we have sulfur, which is 32.07. That's just 1 time, so they make that easy on us. And then there's oxygen, which is 16.00. But there's 4 of them, so I gotta take 16 and add up 4 times. It means 64. So if I want to find the total mass of this molecule here, I'm just gonna add them all up. 28.02 plus 8.08 plus 32.07 plus 64, and I get a molar mass of 132.17 grams. That is the mass of 1 mole. That is the mass of 6.02 times 10 to the 23rd molecules of NH4 2SO4. Randy, you follow along or what? Quick peek at number 12, too. Sometimes because of the parts of the molecule, you might see an element show up more than once. Like 12 says CH3, C, O, O, H. So if I look at the capital letters, I know there's C, there's H, there's another C, there's O. Now, they didn't put these in parentheses. They could have, but they wanted to show this as a specific type of molecule with the CH3 group attached. But it's just the same, I mean, it's the same idea. There's not one C, there's actually two C's, because there's one here and here. H, there's not just three H's, there's a fourth one here. And O, there's two of them. And then you do it the same way. All right, so what time do we get out today? I want you to try to get this done for tomorrow. Just the front side, not the back side. Do not do the back side yet, just the front side. Try to get this done, ready for tomorrow at the beginning of the hour.